Hey y'all, this is just a video explaining what it means to find the vertical and horizontal tangent lines of an equation. So if you've searched this up after struggling with your math tutorial, your math instructions, you probably have, currently at least, or you should probably try and get two equations. Y equals something and y prime equals something else. This is the number up here. That's your regular equation, and the number down here, that's your derivative. So we can use these two numbers to find both the horizontal and the vertical tangent line. And before we get started, I think it's just important to visualize what exactly I mean by the vertical and the horizontal tangent lines. So over here, I have a graph. It's not the graph, the equation I gave. It's just a very simple circle graph. So if you'll notice, I can pick really any point on here. If I go over here, well, that's a tangent line. If I go over here, that's a tangent line. Both terrible, terrible lines, but it's important to note that, let's say I wanted to start a tangent line up here. And of course, that's pretty thick for the radius of the circle, but we can see that this is a totally straight line, a totally flat line. And this is the horizontal tangent line. This is what it's asking for. And of course, there'd be one down here. Ooh, be one down here on a circle tangent or on a circle graph. But you should only really be having a graph that goes like that, or a graph that goes like that, or you shouldn't have more than one vertical or horizontal tangent line. And if you do, it'd be pretty obvious in your answer as to what they'd be. And the same goes for the vertical tangent lines, right here and right here. Ooh. So for a line to be horizontal, make that blue, horizontal or vertical, there's one trait that every vertical line shares, and there's one trait that every horizontal line shares. And that is, on a vertical line, the slope, or m, is equal to, well, it doesn't exist, it's undefined. It's equal to, well, nothing. More nothing than zero, because zero is still a value. But of course, for a horizontal line, m is equal to 0. And of course, 0 is an actual value. So you might have already had a eureka moment in your head where you say, oh, okay, so we know that y prime is the change in, whatever equation we have. So we're looking for two numbers from y prime. One where the numerator will be equal to 0, and believe it or not, one where the denominator will be equal to 0. And before you get all confused, we've been told our entire lives that you can't divide things by zeros as they'll become undefined. Well, that's exactly what we want here. Because the slope of a vertical line is undefined, we want these numbers on the bottom to be undefined as well. We want nothing. We don't want this equation to make sense. So, of course, you solve for your horizontal, and where x is, or sorry, y prime is equal to 0. You can go through this, but if you just take the top and go 7x minus 3 is equal to y prime, because the bottom really doesn't matter in the grand scheme of things, because you're just trying to find when this is equal to 0. So just 7x minus 3 is equal to 0. It's 7x equals 3, negative 7x, of course. And then you just divide by negative 7, divide by negative 7. You get x is equal to negative 3 over 7. So you know the horizontal line is when x is equal to 3 over 7. And for the vertical, we're just trying to find out when 2x plus 1 squared times 7x plus 2 is equal to 0. And luckily, since this is, we're trying to find the product of something, we don't have to worry about this number here, or we just have to worry about this number in here because we're timesing this by the whole equation, or we're timesing this by this by this. So really, we're just trying to figure out when x plus 1 squared is equal to 0. Well, if you haven't been sleeping in class, you should know that -1 plus 1, we'll square that, is equal to 0. And that's true. So x, when the vertical line is, when we're trying to find the vertical tangent line for this equation, x is just equal to -1. And now it's really as simple as, and I've run out of a bit of energy for today, so you can find out the whole equation by yourself using x on either side. But I hope this pointed you in the right direction for trying to find the vertical and the horizontal tangent line.